Hello Year 10 and welcome to your lesson on the Reactivity series. Now I know we did do this before Christmas, but some of you were struggling with it a bit and it's been a while since then, and I really want to make sure that you get this down and you know it before we move on with the rest of this topic. So we're going to be going through Reactivity series again. I want you to write down the date and the title and the LO and try the starter task please. So if you pause the video and do that, and I will continue in 5 seconds. Okay, so answers. Number 1, what is the symbol of gold, the least reactive metal? It is AU. Number 2, what is the symbol of potassium, the most reactive metal? That is K. And name an element that has just one letter as its symbol. So you could have said potassium again, or oxygen, or carbon. I'm not going to list all of them because there are a lot. Okay, so if you just look at the periodic table and just choose one with one letter. Okay, the properties of a metal. I want you to pause the video and I want you to look up the definitions for the following and write them down, please. So pause the video now and I will continue in 5 seconds. Okay, the answers are now up on the screen. So brittle means it's liable to break or snap easily. Malleable means it can be bent into shape. Shiny is a smooth surface that reflects light. Dull is simply not shiny. A conductor is a material that allows heat or electricity to pass through easily. An insulator is a material that doesn't allow heat or electricity to pass through easily. And sonorous means it makes a loud ringing noise when hit. So what I want you to do now is highlight all the words that describe a metal. So we've got malleable. So if you have a piece of metal, you can bend it. Like you'd have to be pretty strong to bend it. It depends what kind of metal it is, but it can be bent into shape. Shiny, we know that metals are shiny when we look at them. Conductor, so it allows heat or electricity to pass through easily. That's why we use copper in our wires and why we have metal saucepans and things like that. And sonorous is if you had metal and you hit something against it, it would make a very loud ringing noise. Okay, so if you have a ruler or something and you gently hit your radiator at home, then it will make a loud ringing noise, kind of like a gong, but not as loud. Okay, so the reactivity series. If a metal is more reactive, it means they're stronger, they react quicker, and they take the place of weak metals in compounds. So this is our reactivity series here. Ignore this bit on the left-hand side. That's just an easier way of remembering it. You don't need to memorize the reactivity series though, so it's fine. But on the right here, we have gold at the bottom, so that is the least reactive, and it goes all the way up to potassium, which is the most reactive. So potassium is stronger than all of the ones below it. It's more reactive than all the ones below it, and it will take place of the weaker metals in compounds. So, for example of displacement reactions, so looking at your periodic table, just quickly look up the symbols for copper, silver, oxygen, and nitrogen, please, because those are all of the elements that are in copper and silver nitrate. So just quickly look them up, please, and I will continue in 5 seconds. Okay, the symbols are on the left now, so we've got Cu, Ag, N, and O. So copper, silver, nitrogen, and oxygen. So because it ends in 8, silver nitrate, it means there's oxygen as well. Okay, so we've got silver, nitrogen, and oxygen are bound together to form a compound. So these three here are all bound together to form a compound. So they're together, copper is just by itself. If we add copper into the mix, if you look at the periodic table, copper is towards the bottom, but it's still higher up than silver. That means that copper is more reactive and it will replace silver in the compound. So here we have the formula. We've got copper plus silver nitrate. So here's the compound, there's copper by itself. Because copper is more reactive than silver, it's going to kick silver out, and copper is going to bind to the nitrogen and oxygen as well instead to create copper nitrate. And then silver is by itself. So all you're doing is replacing one metal with another, and that is called a displacement reaction. So obviously, if I could fit it all on one line, I would. When you write these out, write it all on one line, please. The reason I've done it underneath is just because I ran out of room. So when we have formulae like this, the things on the left side of the arrow, those are the reactants, so the things that react together. And the things on the right side of the arrow are the products, so the things that are made. So copper is more reactive than silver, so it replaces it in the compound. This is called a displacement reaction. I want you to write down this example, please. So pause the video and I will continue in 5 seconds. Okay, what I want you to do is I want you to try and finish these equations. So you need to be looking at the reactivity series. So you can either go back a few seconds in the video or you can open a new tab on Google and type in reactivity series so you've got it there for reference. It will be the same one because the reactivity series doesn't change. Okay, so I want you to finish these equations. You need to make sure you're looking at whether there is a reaction or not, because some of them there won't be a reaction because the metal that is added in won't be more reactive than the one that's in the compound. So you need to make sure that you are looking at the reactivity series, please. Okay, so pause the video here and I will reveal the answers in 5 seconds. Right, the first one. Magnesium is more reactive than silver, so it will go to silver plus magnesium oxide. Okay, there is no reaction here. You can see it's the same on the left side as it is on the right side. So you can either just write out exactly the same as it says on the left, or you can write no reaction, because platinum is not more reactive than calcium. Okay, next one, aluminium plus lead chloride. Aluminium is more reactive than lead. So it replaces lead in the compound. So now it's lead plus aluminium oxide. Oh, chloride. Sorry, I wrote oxide, but it's supposed to be chloride. Okay, and last one, zinc is not more reactive than potassium, so it stays the same. So you can either write it out again, or you can just write no reaction. Okay, now we're going to do the examples using the symbol versions. So if you try these, here are the answers. Zinc is not more reactive than lead, so there is no reaction. Calcium is more reactive than iron, so we have calcium oxide plus iron. And sodium is more reactive than silver, so we've got sodium chloride plus silver. Give yourself a mark out of 7, please. Okay, so why is the reactivity series so important? So most metals aren't found in their pure forms. We have to dig them up from the ground where they have reacted with other metals to form ores. So an ore is a naturally occurring solid material from which a metal can be extracted. I want you to write down that definition, please. So if you go digging in the ground for gold, you're not going to get a pure bar of gold. It's going to have reacted with other metals to form an ore. So thinking about, well, those of you who do play Minecraft, there is a reason that I have Minecraft as a theme for this lesson. If you think about what you have to do to get a metal from its ore, you would most likely think a furnace, and you would be correct. This is how it works in real life too. So we are now going to go through why this works. Okay, so you put the iron ore in the furnace, and then you come out with iron. But what do you have to put in the furnace to make it work? You have to put in wood or coal into the furnace, and I'll explain why on the next slide. Okay, so when we burn a fuel such as wood and coal, carbon is released. So when we burn either of these, carbon is released. Now look at where carbon is on the reactivity series. Okay, it's quite high up. So all these ones below it, it will displace, and we will be able to get the pure metal if we burn it in a furnace with carbon. Okay, so that is why we can burn things in a furnace and we get the pure metal from the ore, because carbon displaces it, like the examples that we've just gone through. Okay, so that is the end of today's lesson. We are going to talk about how to extract metals above it in a different lesson. Okay, so that is all for today. I hope you all have a wonderful day, and I'll see you soon, I guess.